Imagine for a moment that you are back in 1985.
Mm-hmm.
You've got your home computer set up, maybe a shiny new Commodore 64 or an Apple II sort of glowing in the corner.
Right.
And you have an image in your head, a design you want to see on that screen. Let's say, just a simple circle,
Sure. Or a line.
a bold, thick line. If you were using the standard methods of the day, unless you were running some serious, professionally priced CAD equipment.
Which nobody at home was.
Exactly. Drawing that circle meant typing in lines and lines of mathematical coordinates. It meant commands like PLOT, XY, then calculating all the parameters. It was a grueling programming assignment.
It was a massive barrier. I mean,
Yeah.
creativity was just shackled by syntax. Martin Banks, a reviewer writing for Personal Computer World back in January 1985, he really captured that frustration.
He did.
He asked the reader if they'd ever seen these beautiful computer graphics and then just immediately given up because of the sheer amount of program coding needed. That was the reality for anyone who wasn't a programmer but, had an artistic impulse.
Absolutely. The keyboard was a text device, but we needed a graphical one. And this is where our deep dive begins today. We're looking at the piece of hardware that promised to just obliterate that code barrier.
The Koala Pad.
The Koala Pad. It was this revolutionary, touch-sensitive unit, and according to the hype, it was supposed to unleash the inner Picasso in all of us.
And that is our mission today for you. We're taking the sources and we are extracting the most critical and often contradictory insights from the reviews of this thing. We need to focus on the central question. Did the Koala Pad truly deliver on its promise of quality, easy graphics?
Or did it ultimately succumb to what the reviewer eventually called its fundamental and crippling technical weaknesses?
Exactly. Was it a genius invention that was just hobbled by the technology of 1985?
We're looking at a technology born out of a real need, to democratize digital creation for the home user. It was certainly not marketed as a professional, high-tech drafting device. The goal was access.
Precisely. And the documentation confirms this. The Koala Pad was aimed specifically at the home and hobbyist market. However, and this is an important bit of context, while the UK review we're focusing on really zoned in on the Commodore 64.
Which was everywhere in the UK.
Everywhere. The device was also available for the IBM PC and the Apple II in the US. And in those markets, it did have some pretensions towards business use.
Right.
But for the C64 owner, the focus was purely on affordable, creative fun.
That's a key distinction. It means we're judging the Koala Pad not against high-end corporate tools, but against the sheer frustration of the average kid trying to draw a rocket ship on a screen that only understood commands.
Okay, so let's unpack this device. What was this thing and who brought it to the market?
Right. The Koala Pad was manufactured by a company called Koala Technologies Corporation based in California. But for the UK market, which, as you said, was just saturated with the Commodore 64, the distribution and the marketing fell to a company called Audiogenic.
And Audiogenic made a very strategic choice there, didn't they? Oh, absolutely. They concentrated their efforts almost exclusively on the Commodore 64. The C64 was a behemoth in the UK scene at that time.
So the whole experience of the Koala Pad in Britain was intrinsically tied to the C64's capabilities.
Exactly. Its limited color palette, its specific sound chip, and crucially, its relatively low screen resolution.
Okay, let's get into the physical specs and the design, because this is where the first major contradiction, I think, starts to emerge.
I agree.
The pad is a touch-sensitive unit housed in a plastic shell. And the overall footprint of the case is actually pretty substantial for the era. 6.5 inches wide by 8 inches deep.
It gives the impression of a really generous drawing surface, doesn't it? Something you could really rest your hand on and work with.
Yeah, it looks professional.
It absolutely looks professional, and that visual impression is key to its appeal, and probably to justifying the price tag we'll get to. But here's the critical distinction.
The catch.
The catch. The one that defines the device's main flaw. The active drawing area itself, the surface that actually registers input, is tiny.
How tiny?
It measures a mere 3.5 inches by 4 inches.
Wait, hold on. So the usable area is less than a quarter of the visible case size. That's remarkable.
It is. It's a complete design paradox. You have this relatively large piece of plastic you're meant to hold and brace, but you're forced to operate in this highly restricted, tiny sensor space right in the middle.
And that size difference, that gap between how it looks and how it works, becomes key to its flaws later on.
It's central to understanding everything that goes wrong.
So I have to ask,
Why?
why? Why do that? Was it just a sales tactic to make the price tag feel justified? Or was the large shell needed to house all the electronics?
That's a great question, and the review doesn't explicitly say, but we can speculate. It's almost certainly a combination of both. Manufacturing a large sensor pad that was accurate and affordable in 1985 would have been incredibly expensive. So by using a smaller sensor, they kept the costs down. But the larger casing was necessary to provide stability for two-handed use and, like you said, to create a psychological justification for the price. It had to feel substantial.
Even if the working area wasn't.
Exactly.
Now, let's look at the operational design. The case itself has 2 keys on it, and the reviewer notes that both keys do the exact same thing.
Yeah, that redundancy is a direct response to the ergonomics.
Yeah.
The design assumes a specific and kind of awkward operation.
Right.
You're meant to hold the case in one hand, left or right, with your thumb resting over one of those keys. This leaves your other hand free to work the pad with a stylus or your finger.
So it's a 2-handed operation right out of the box. You're bracing it with one hand while controlling the drawing stick, key pressed or not, and then actually drawing with the other.
Precisely. It immediately kills the fluidity of just, one-handed sketching.
And what about the input methods? What could you actually use on the pad?
They had some flexibility there. You could use the stylus that came with it, you could use a finger, or, and this is a great detail from the source, any other reasonably pointed and hard object.
So a pen cap, the corner of a ruler.
Anything, yeah. It tells us the mechanism was pressure-based, not some complex digital pen technology. It just responded to anything that could register pressure on that small area.
Okay, shifting gears to setup. Connectivity. How easy was it for the average person to hook this thing up?
That was one of its undeniable strengths. For the Commodore 64, the Koala Pad interfaces directly by mimicking a standard joystick.
Oh, that's clever.
It is. You just connect it to port 1 of the computer. That's it. No complex drivers, no messy serial cables. Plug and play 1985 style.
That simplicity was absolutely essential for that hobbyist market.
Assuming you could get past the 7-minute load time, but we'll save that trauma for the next section.
Right. Okay, here's where it gets really important for our listeners. The price. If this was supposed to democratize art, the price tag is the gatekeeper.
And it was a big one.
The Koala Pad cost £79.95, including VAT, back in 1985.
That was a monumental outlay for a peripheral. To really understand the investment, we need to adjust for inflation. That's £79.95. That's roughly £250 in 2023.
Wow. Okay, so you're spending the equivalent of a high-end gaming keyboard today just for this small drawing tablet.
Or maybe a third of the cost of a decent laptop. It was a huge financial commitment. It means the person buying this wasn't just casually curious. They were serious about graphics, or maybe just desperate to avoid programming.
Which is why the reviewer's initial verdict is so fascinating. Despite all the drawbacks we're about to get into, Martin Banks concludes that at the price, it's an excellent exploitation of technology.
And a worthy competitor to a mouse. That's a huge claim for the time.
I have to push back on that, though. If it cost £80 in 1985 and its main freehand function was, as we'll find out, basically broken, wasn't it more of an exploitative price for a half-finished device?
The optimism comes from the concept. In the mid-'80s, the mouse was still an exotic thing, associated with the Mac or expensive workstations. For the C64 user, a graphics input device that wasn't the keyboard was revolutionary.
It was tactile.
It was tangible, yeah. The potential value, the ability to just bypass code and create something visual immediately that was so high that it momentarily justified the steep price and the technical limitations. It was selling the dream of digital art, even if the dream was a little bit jittery.
So we've got the hardware identity and the price barrier. Now we need the brains, the software. The pad needed software to turn those stylus movements into pixels.
And that software came from a company called Audio Light Inc. of California. They created a necessary trilogy of packages.
The first and most important was the core package for graphics, Koala Painter.
Right, this is where most of the creative work happened.
Then you had the support packages, Koala Printer, which was essential if you wanted to get a hard copy of your results. I mean, pre-internet, that was often the only way to share your creation.
And the third package speaks directly to that hobbyist 8-bit era spirit, the Instant Programmer's Guide.
I love this.
Yeah, it's explicitly aimed at users who wanted to interface the Koala Pad to other programs. And the source material notes that this was considered a relatively easy task to accomplish.
That's a brilliant move. They weren't just selling a drawing program, they were selling a versatile input device that could, theoretically be used to control other games or utilities. It fueled that early spirit of user-driven hacking.
It maximized the return on your expensive hardware. If you could use the pad for more than just drawing, that 80 pounds investment suddenly seemed a bit more palatable.
Now, for a little detail that I just find fantastic. Audiogenic, the UK marketer, they produced an anglicized version of Koala Painter.
Mm-hmm.
And the main modification was not a fix for the jittery cursor. It was allowing circular circles to be drawn, because the American version produced slightly elliptical ones.
It's a great, almost comical quirk of early software localization. It highlights a subtle difference in programming. The Commodore 64's pixels were not perfectly square.
Right.
So if the software didn't correctly compensate for that aspect ratio, a geometrically perfect circle command would just appear stretched in ellipse on a standard TV.
A philosophical difference between British and American geometry. It shows that even back then, users were discerning. If you bought an expensive tool to make drawing easy, the fundamental shapes had to be right.
Absolutely. The last thing you want is to draw a circle and get an oval because the programmer forgot to check the aspect ratio.
Speaking of user frustration, let's talk about the experience of getting started, specifically the load times.
Oh, this is where the grim reality of 8-bit storage just hits you hard. The reviewer initially tried the cassette tape version, but it just refused to load.
A common problem.
Very common. So he had to switch to the American floppy version for the test.
Okay, let's assume the floppy disk, the faster option, worked. Step 1. You put in the floppy. You type aloo KPA1NT.
Step 2. The drive whirs and clicks, and you wait. You wait about a minute for the computer to load the initial boot segment and give you the ready prompt back.
But that's not the program yet.
Not even close. That's just the launch prep.
Step 3, and this is the killer. You type in RN, then you wait a further 5 or 6 minutes until the main menu finally appears.
We are talking about a total load time of around 7 minutes just to open the main drawing application.
In an era where you want spontaneous creativity, a 7-minute boot time it's a flow killer. You don't casually load Koala Painter, you dedicate your evening to it.
It's the digital equivalent of waiting for paint to dry, only you're waiting for the canvas to appear. It's a fundamental contradiction to the promise of easy and immediate graphics.
And the fun doesn't stop there. Once the program loads, the user experience greets you with another sensory contradiction, the buzz and bleeps conflict.
This is the truly unique flaw. As soon as the program is running, the television volume emits a continual and annoying mixture of buzz and white noise.
So your first instinct is just to mute the TV.
But you can't turn the sound off, because the pad's interface relies on crucial bleeping sounds from the television. These bleeps are the essential audio cues that tell you you've successfully selected a function, or you can switch modes.
So you're trapped. You have to endure this continuous static, which was probably from poor electronic shielding, just to hear the little bleep that confirms your action work.
It's a perfect example of a design compromise. They shoehorned the feedback mechanism through the only reliable output they had, the TV speaker. They prioritized function over aesthetic experience, and it resulted in this truly frustrating soundtrack of static.
It sets the stage perfectly for the technical flaws we're about to discuss. Everything about the Koala Pad so far, the misleading size, the two-handed operation, the 7-minute load, the constant buzz it all, suggests the execution of this great idea was just fundamentally messy.
Okay, so you've endured the 7-minute load, you've accepted the white noise, you're finally at the Koala Painter menu. What did this revolutionary interface actually look like? It was entirely visual. The main menu was a series of separate boxes, each with a different command, all displayed in a rectangle with a colored border. A visual command center, no typing required.
And navigating it was all driven by the pad. You move the stylus up the pad, an arrow cursor appears on screen.
You move the cursor over a command box, say circle or draw. You press one of the keys on the pad, and that command is selected. Confirmed with a visual blink and that all-important bleep.
And to get back to the drawing screen from the menu, you didn't click an exit button.
No, you had to physically move the cursor down to the very bottom of the pad, past the visible screen, until you heard that crucial bleep.
Then you press a key again, and the menu vanishes.
It's a complex physical choreography for a simple action. It's not intuitive in the modern sense. It's a learned sequence of movements and sounds.
Now the core function, drawing, freehand. How did that work?
You select Deal Draw. You press one of the keys on the side of the pad, and then you must keep that key pressed while you move the cursor around to draw.
That's a key detail. So to move the cursor without drawing, what do?
You had two options. You could lift the stylus off the pad and put it back down, which is imprecise. Or, the more convenient method, you just release the key until the cursor is where you want it, then press it again to continue drawing.
Which, again, re-emphasizes that two-handed operation. One hand is the on-off switch for drawing, the other is aiming.
Right. It feels less like sketching and more like controlling a machine.
What about the artistic tools, the brushes?
The software offered 8 different brush effects. Not just line thickness, but things like a narrow point, broad brushes, and even multiple brushes that let you draw several lines at once.
For patterns and things.
Exactly, for decorative and architectural stuff.
But we need to pivot immediately to why those were probably a necessary distraction. Because the major problem Martin Banks found was when he tried to use the freehand to draw command.
Yes. In his words, it was impossible to keep the cursor still.
The hardware, designed to enable free creation, actively sabotaged it.
But this is where the automatic drawing commands came in. The reviewer noted that these automatic functions largely overcame the freehand problems. The software was correcting for the hardware's failure.
Okay, let's detail these commands because this is where the Koala Pad actually redeemed itself. They fell into 2 categories, right? Linear and solid.
The linear commands were things like line, lines for connected lines, frame for rectangles, circle, and raise, which let lines radiate from a central point.
And the solid commands?
BAC and DSC for filled-in rectangles and circles, and the powerful separate fill command.
So how did you use these?
The process was standardized and beautifully simple. You select the command, say circle, you press a key, go back to the drawing display. You fix the start point, the center of the circle, by pressing the key. Then you move the cursor to select the end point, which sets the diameter, and you press the key again.
And the shape appears instantly.
Instantly and perfectly straight or perfectly curved. The entire process was deemed extremely quick and easy because the computer was doing the geometry, completely sidestepping the user's unsteady hand.
It effectively turned the Koala Pad from a freehand drawing tool into a geometric shape plotter.
That shift is profound. The flaw forced the user away from their natural analog impulse to sketch and toward a highly structured digital construction.
Let's talk about the fill command for a second, the paint bucket tool.
Revolutionary and terrifying. It lets you flood fill enclosed areas with color, but it requires careful, high-stakes use. You have to make sure you haven't left any holes.
Because if there's a gap, even 1 pixel,
the color escapes and everything will be painted the same color. It's a high-stakes mistake.
But beyond the drawing commands, the Koala Pad had some utility commands that feel incredibly modern. The star of the show has to be OPS.
OPS, a single-step undo feature. This was crucial for encouraging experimentation and for mitigating the risk of that fill catastrophe.
Then you had tools like mirror, which reproduces what you draw in one corner as mirror images in the other 3, a kaleidoscope effect.
That's genius for early digital art. You can instantly create these complex, repeating patterns without having to manually copy and paste anything.
There's also Xcolor, to refill an area with a new color, and Copy Y, a step-and-repeat facility.
And significantly zoom, which let you magnify an area for detailed pixel-level work, which was essential if you needed to find that one missing pixel that caused the fill command to explode.
Right.
And finally, swap, which let you move picture information between windows. These utility functions, OPS, mirror, zoom, they really show the sophistication of the software, compensating for the hardware's shortcomings.
They are the reason the Koala Pad was called an exploitation of technology. It wasn't the touchscreen itself that was brilliant, it was the software that made you productive, despite the hardware. We have danced around this long enough. We have to confront the heart of the issue now, the element that defined this thing's creative ceiling.
The wobbly cursor.
The reviewer, Martin Banks, was unambiguous. The major problem was the jitter and the resulting inability to draw straight lines in freehand mode.
It's the ultimate contradiction, isn't it? You buy a sensitive drawing pad to draw, and that sensitivity is so high it makes the simple act of drawing a straight line impossible.
And the movement wasn't just a slight flicker. The deviation was, what, no more than a Commodore sprite or 2?
Which sounds small, but on a 320-pixel wide screen, a sprite could be dozens of pixels. That's a huge visible lurch that utterly ruins the line. It restricts your creative output entirely to the geometric shapes.
This is the pivot point of the device's legacy. The hardware was sold on the promise of freehand freedom, but the reality was that freedom was curtailed. But this is where the company's defense comes in.
Right. Audiogenic was clearly ready for this criticism. They suggested this jitter was, and I quote, expected of the device.
Expected. That's an extraordinary admission for a product sold at a premium price.
They essentially admitted to a fundamental defect in the core function. And they presented a multi-pronged justification for why the cursor was wobbly.
Okay, let's dissect their defense. Point one.
Defense point one. The device is not intended for professional hand-drawing capabilities. It's for the hobbyist. So they immediately try to lower your expectations.
Defense point two. The automatic drawing commands, the circle, line, and .x functions, are intended to largely overcome the problem.
They're basically saying, we know freehand doesn't work, so use the geometric tools we designed to bypass the issue.
Right.
And defense point three, the core technical explanation, which ties right back to that sizing issue we flagged at the start. The major reason for the instability is the pad's small active area, 3.5 inches by 4 inches.
We need to break down the physics of this. The review says the merest hint of a hand tremor is translated into a major movement on the screen.
Think about the mapping ratio. You have this tiny physical drawing area, 3.5 by 4 inches. But it has to map those tiny movements onto a screen that's 320 by 200 pixels wide. That's a massive scaling factor.
So if you move your finger 1 millimeter on the pad, a natural, unavoidable tremor, that 1 millimeter gets magnified into a huge jump on the screen.
Exactly. The human hand, even when still, has micro tremors. When you're trying to hold this thing with two hands and apply a stylus to that tiny area, even a slight pulse in your hand would be magnified into that ruinous, visible wobble. The required mapping ratio made precision impossible for human anatomy.
So the very design choices intended to keep it affordable actually doomed its primary function.
And this leads right to the final drawbacks noted in the review's conclusion. Beyond the wobbly cursor, the other big flaw was the need for two-handed operation, which the reviewer said could prove a problem.
I have to challenge their defense again. When the company says the geometric commands largely overcome the problem, aren't they just admitting they sold a drawing device that can't draw?
That's a fantastic metaphor. It's like selling a bicycle that can only ride downhill and say the automatic brakes compensate for the lack of pedals.
Right.
And it gets to the core philosophical question. The Koala Pad represents that moment when digital art had to decide if it prioritized analog input, like freehand drawing, or digital manipulation, like geometric plotting. Because the hardware couldn't handle the first, the software had to excel at the second.
And the market accepted that trade-off.
They did, because the geometric tools themselves were so novel and effective, and the alternative was hours of coding. The Koala Pad, therefore, taught early users that digital art must be precise and command-driven. It forced you to think structurally.
Before we deliver our final verdict, we should note that, despite the hardware, the 7-minute load, and the audio quirks, it wasn't a total mess. The documentation was apparently pretty good.
Yeah, generally clear and concise. That's a genuine relief for the era. Good documentation meant users could actually understand and use all those clever utility commands like OPS and mirror.
However, there was one single documented weakness found in the storage routine.
Right, the system for saving and retrieving pictures.
A crucial function.
A critical function. The reviewer found that the retrieval routine, called getDet, wasn't fully explained in the original manual. And if you can't get your masterpiece back, the whole thing is wasted.
Thankfully, this was corrected with an addendum sheet that came with the pad. Though the reviewer admits he forgot to check it at first and learned the hard way after one of his drawings just vanished.
The addendum clarified a necessary, if slightly bureaucratic, two-step retrieval process.
What was the logic?
Before using the GT command to retrieve a file, you first had to go through the name routine.
The same routine you used to name the file before saving it?
Exactly. You had to run name again to identify the file you wanted to retrieve. Only after you identified the file via name could you then run the GT routine.
It's a classic early computing handshake that isn't logical. The computer needed a reference pointer before it could execute the load command. And if the manual misses that single prep step, the whole retrieval process fails.
It's a procedural tripwire that could lead to immense user frustration, especially after that 7-minute load.
But the fix was simple enough for the time. Read the addendum.
So after this deep dive, what does the Koala Pad represent historically? I mean, the device, reviewed in 1985, was truly innovative in its promise. It successfully liberated budding computer artists from the tyranny of programming code.
It offered high entertainment and educational value, and it was quick to give results, as long as you were using the automatic commands.
Right.
But it was profoundly technically hobbled. We have to acknowledge that trifecta of design flaws: the jittery cursor, caused by that fatal mapping ratio, the required two-handed operation, which made it awkward, and the white noise audio bug, which was just this irritating soundtrack to creation.
And yet, despite all of that, The final verdict from the reviewer was overwhelmingly positive. He called it an excellent exploitation of technology.
It demonstrated how technology, a cheap, touch-sensitive pad, could be applied to complex visual applications at a, well, reasonable price for the time.
And the reviewer explicitly called it a worthy competitor to a mouse. That statement, in 1985, that's the ultimate praise. It shows a market was actively seeking alternatives to keyboard input for graphics, and the tactile tablet was a viable, if flawed, path forward.
It showed that graphics input could be tactile, not just programmatic.
Ultimately, the Koala Pad's genius was in its software compensation. The device failed at the most basic human function, drawing a straight line by hand, but it excelled at the most precise digital function, plotting perfect geometric shapes instantly.
Which brings us to our final provocative thought for you to explore further, building on this paradox we've uncovered. The Koala Pad's success hinged entirely on the power of its automatic geometric commands lines, circles, boxes. So, given the hardware limitations of the era, how much did this democratization of easy geometric shapes truly compensate for the complete failure of freehand drawing? And what does that compensatory strategy where software saves broken hardware say about the early priorities of digital art?
Did the Koala Pad inadvertently define the aesthetic of early computer graphics by forcing artists into structured design and geometric construction, simply because the technology couldn't support the fluid, messy nature of human expression? It's a question that the Koala Pad's jittery genius forces us to confront.
7 minutes after we hit the RUN command. If you enjoyed this trip through the pages of computing history, make sure you follow or subscribe so you don't miss our next deep dive.
Until next time, may your pixels stay perfectly aligned, even if your stylus hand is wobbling.